Good afternoon, everyone. So, next algorithm of which is related to mathematical analysis of non-recursive algorithm is binary. Okay, and the problem is like this: the for algorithm to find the number of binary digits in a binary representation of a positive decimal integer. Okay, so we should take one positive decimal integer, and for that we should find out the binary representation, and then how many number of binary digits we get out of it. That is the problem. Okay, first we will be taking one positive decimal value, and for that we need to convert that decimal into binary representation. After converting it, we should get how many number of binary digits are there in that particular decimal number. Okay, that's the problem, and for that I have written the logic of that here. See, let us take the decimal number 19. Okay, so decimal number is what? N value is what? 19. Okay, so in the first iteration, what we should do is to convert this decimal to binary and to count the number of digits. So the first step is going to be this decimal value should be divided by 2. Okay, so 19 divided by 2 will be equal to 9 point something we get. So here the point value should be truncated, and we should consider only the integer portion. So integer portion here is 9, and for 9 the corresponding binary representation is 1001. Okay, so we started with this 19, and its corresponding binary equivalent is 10011, and we should increment count value by 1. Okay, and in the next iteration you should divide the decimal number by 2, and we should get the corresponding binary equivalent, and meanwhile increment the count value. Okay, and then in the next iteration we got, in the previous step we got 9. Again 9 should be divided by 2, it is equal to 4 point something. Take only the integer part, truncate the decimal part, and 4 corresponding binary representation is 100, and increment the count value. Count value is now 3. And in the next iteration, take the previous value, divide by 2, it is equal to 2, binary equivalent is 10, and increment count value by 1. Now it is updated to 4. And in the next iteration, so take the previous value of 2, 2 divided by 2 is equal to 1, and corresponding binary equivalent is 1, and count value update by 1, that is equal to 5 now. Okay, so now we cannot further move to the next step, because 1 divided by 2 will be equal to 0, no? So which means that we are supposed to stop the algorithm at this point of time. Okay, so at this point of time, in the sense when n value is 1, you are supposed to end, you are supposed to terminate, loop should be exited out of it. Okay, understood girls? What we did here, we took one decimal number, every time the decimal number should be divided by 2, and we find the corresponding binary equivalent and increment value of count. That should be written as algorithm now. Okay, so here we will be taking one variable called as count. So initial count value would be 1. Okay, so every time what we should do is we should check n value should be greater than 1, because here we got to know, no, n value should be greater than 1. Okay, so it should be always greater than 1, then only we can perform division. If it is equal to 1, then we cannot perform division. So that's why we have made this instruction saying that n value should be greater than 1. If n value is greater than or equal to 1, then we cannot divide it. Okay, we will get something, some other solution to that. So make sure that n value should be greater than 1. And if n value is greater than 1, for this case, let us take n value is 4. N value is 4. 4 is greater than 1. Condition is evaluated to true. If condition true, update the value of count. Update the value of count. Initial value of count was 1. If you update, 1 plus 1 is equal to 2. So here we get 2. Okay, and after that divide n by 2. Okay, so what is the value of n? N value is 4. 4 by 2. 4 by 2 is equal to 2. 2 will be updated to the value of n. Okay, and then return the count value. Okay, so here we have, okay, So we divided and we are here in this step. Okay, so we divide the value. Before dividing, we should check this condition. N value is now updated to 2. 2, is it greater than 1? Yes, condition is evaluated to true. Count value, it was 2 before. Now 2 plus 1 is equal to 3. 2 by 2 is equal to 1. Okay, 2 by 2 is equal to 1, and return the count value. Count value is 3. Okay, I repeat again. So you should take initial value of count to 1 and assume that initial value of n is 4. Okay, assume that initial value of n is 4. 4 is greater than 1. Condition is evaluated to true. Increment count value. So previous value of count is 1. 1 plus 1 is the updated value of count, that is 2. Okay, so now 4 divided by 2 is equal to 2. N value is updated to 2. Okay, so count value is what? Count value is 2. N should be passed to this function again. So instead of 4, now it is 2. 2, is it greater than 1? Yes, condition is evaluated to true. Update the value of count. We had in the previous step the count value was 2. If you update, it is 2 plus 1 is 3. Okay, now if we perform 2 divided by 2, answer is 1. So now return the value of count. Count value is 3. Okay, and n value is again updated to 1. 1, is it greater than 1? Condition is evaluated to false. What is the final count value we got? 3. Okay, so now what is the binary value of 4? It is 3. 4 is 1003. So total we have 3 digits, and that 3 digits we got. Okay, so that is this problem. And how do you write the loop now? So how do you find out the time complexity of the algorithm? So time complexity of the algorithm, you can find it like this by writing down. So here we have the initial value would be, no, we don't have initial value here, no, for this one. So what I do is, here in this case, upper bound should be, it has to run from, sorry, this is not the time complexity.